In my last video about unit cell, I hope that you have watched and have subscribed. In that video, I had given you the clear concept about the unit cell and their types. Now, today's videos is on calculation of number of particles present in different types of unit cells. There are different types of unit cells you have studied in my last video. In unit cells, the particles are located at different positions. It means in unit cells, different unit cells. See here, there are 4 different types of lattice points. There are 4 different types of lattice points. Different types of lattice points. What do you mean by the lattice points? Lattice points means the position or location of the particles in unit cells. So I shall give you the tricks, simple method, simple formula to derive the number of particles present in different unit cells. We have seen there are 4 different types of lattice points, 4 different types of location of the particles. First, particles located at corners. Particles located at corners, that is in simple unit cells. Second type, the particles that will be located or present at the center of the faces. It means particles located at the center of faces. And the third may be the particles may be at the center of the unit cell. It means particle located at the center of the body, of unit cell. And the fourth is here. If you see here, the fourth, that the particles may be at the edge of the unit cell. It means particles at the edge of unit cells. See here, there are 4 different types of lattice points, 4 different types of ways at which the particles may be present. It will always be present at the corner. It is compulsory. But these may be, the particles may be at the center of each faces. Particles may be at the center of the body of unit cell, or it may be at the edge of the unit cells. But we have to see the contribution of the particles in one unit cell. How much part of the particles can be contributed in one unit cell? Suppose just I am going to draw, see here, just I am going to draw the figure just like you see here. There are 8 figures. What you see here, there are 8 unit cells. 1, 2, 3, 4. Suppose the particle lies at the corner. Suppose this is the corner of unit cell. Just I am going to see here the unit cells. See here the unit cells. In this case, see here unit cells. See the unit cell. This is the unit cell. And particle lies at the corner. So here one particle lying at the corner is contributed by 4 unit cells at one level, at one layer, and there would be 4 unit cells at the upper layers. So the particle which lies at the corner is attached with 8 unit cells. It means it's 1/8 part of the particles will be in one unit cell, because the whole particle is attached with 8 unit cells. So in one unit cell, 1/8 part of sphere or atom is present in one unit cell. In one unit cell. See here particles located at the center of faces. See here the face. Suppose the face is here. Face is here. Suppose face is here. And this is the face. This face is here. And its half part will be inside the unit cell, and the other half will be in the other unit cell. So the particles that is located at the center of the faces, its contribution would be 1/2. Its contribution would be 1/2 in one unit cell. One in unit cells. Again, just see, I am just explained these two. Now the particles located at the center of the body in unit cell. Center of the body, this is unit cell, and its center, it means the whole part of the sphere lie inside the unit cell. So there would be the complete contribution of the sphere in the unit cell. It means it is whole of the particle is in unit cell. Unit cell. Now in fourth case, just particles at the edge of the unit cell. See here the edge of the unit cell. Edge of the unit cell. If you see here, the edge, this is the edge. At this point, there are so many edges, 12 edges. So see here at the edge. So this edge is attached with 4 unit cells. See here, just in front of it, just above it, and just other side. So its 1/4 part lie in one unit cell. It means, what do we mean? 1/4 part of one particle lie in unit cell. Unit cell. Just you have studied about the part of the unit cell contributed in the unit cell. Part of the particles contributed in unit cells. Now see here, just in a simple way, if you have to find the number of particles in different unit cells, so uniformly we can calculate the number of particles in unit cell. Particles in unit cell. First, particles lying at the corners. See here, particles lying at the corner. If you add, there are 8 corners and the 8 particles lying at the corner, but its contribution is 1/8. So 1/8 into particles lying at the corner, that is NC, means number of particles lying at the corner. Again, if you see the next particles lying at the center of the faces, see here, center, this face is here, so its contribution is 1/2, and there are 6 faces. How many faces? 6 faces. There are 6 faces, so there would be 6 particles, but their contribution of 1 particle is half. So 1/2 into number of particles at faces. Face center, FC, face center. Is it clear? Again we will see the particles lying at the edge. So see here, particles lying at the edge, that's contribution in the unit cell is 1/4. So we will write here 1/4 contribution of total number of particles lying at the edges into number of particles at the edges. Again, the fourth lattice point is at the body center, and at the body center the whole of the particle is contributed in the unit cell. So 1 into number of particles at the body center BC. So if you add this, you can easily calculate the number of particles in unit cell, in different unit cells. Suppose you want to find out the number of particles, as for example, suppose number of particles or atoms or spheres, number of particles in FCC, you have to find out. So number of particles in FCC, you must have to first know about the location of the particles, location of the point at which the particles lie. In it, first of all, the particles lie at the corners. So there are 8 corners. So see here, 1/8 into 8. As well as the particle also lie at the center of each faces. Center of the faces. Its contribution of 1 particle is 1/2. If it lies at the face center, 1/2, and total number of particles would be 6 because there are 6 faces. So 6 is here and its contribution would be half of each particles. Now we will see the edges. There is no particles lie at the edge center. It means 1/4 into 0. Again, there is no particles lie at the body center. It is also 0. So we got here 8 cancel, that is 1 plus 2 3 are 6, that is 3, and other is 0. It means there is 4 particles. 4 particles. It means 4 atoms present in FCC. Similarly, you can find out the number of particles in other types of unit cells. What is its use? Why we calculate the number of particles? Where is it going to be applied? It is applied first application. Its application. Why we will calculate the number of particles? It is used to determine the formula. To determine formula of compound. Formula of compound. It means, as for example, suppose at corners A lies at the corners and B lies at the faces. So what would be its formula? That is AB3. So it is used to determine the formula of a compound. What is its second use? It is used in calculation of packing fraction or packing efficiency. We can use this number of particles to find out the packing fractions. So these are the uses of the number of particles in different unit cells. I think you will like it, and sure you will subscribe the channel, and you may also put comment to me. Thank you for the next videos.